Okay, so the first thing we're going to do is we're going to look at each problem and figure out what f of u is and what u of x is. So our first problem is 1 over 4x squared plus 3 quantity cubed. So f of u is going to be 1 over u cubed, and u of x is going to be equal to 4x squared plus 3. Now, before you take the derivative of this, you'll need to rewrite it as u to the minus 3 power. Okay, next one. 3 times x to the 5th plus 3x cubed plus 7x cubed. So in this case, f of u is 3u cubed, and u of x is x to the 5th plus 3x cubed plus 7x. Again, I think it's in the parentheses. Okay, next one. So it's really just like the last one. You have f of u is 2u to the 5 halves, and u of x is x squared plus 2x plus 5. Again, u of x is in the parentheses. Okay, so now we have a sine function. Inside the parentheses we have u of x and f of u is the sine of u. Again, the whole idea here is that you're trying to break it up into two functions that you do know how to take the derivatives of, that we have a formula for, that we've derived previously. Okay, the next one, 5 divided by the sine to the 4th of x. So this is where you need to rewrite the sine to the 4th as the sine of x raised to the 4th power. So again, in the parentheses we have u of x, which is the sine of x, and f of u is 5 divided by u to the 4th power, which again we have to rewrite as 5 times u to the minus 4th power. Okay. In this case, it's not in parentheses, but it is in a radical. So that u of x is 4x squared plus 3x plus 7, and f of u is 1 over the square root of u. In this case, we have to do two things. We have to rewrite the root as a fractional exponent, and then we have to move it to the numerator like that. Okay, argument of the trig function is 5x squared. F of u equals the secant u. Now I came up with the derivative of the secant the other day using the quotient rule. this one is a combination of product rule and the chain rule. So the second term is we're going to call that g of x. And we can rewrite that as the sine of x quantity squared. And the first part of the product is 5x to the fourth plus 4. Now, in this case, we don't have to use the chain rule for this. It's just a polynomial, but we do have to use the chain rule for that. So basically, you have to, instead of just being able to go from here to here and get the derivative, you have to spend a little extra time getting that derivative, which we'll do on a separate page, and then we'll take that result and put it in here. So, we're going to need f prime of x here, which is easy, and the g prime of x we'll get from doing it over here. So the chain rule applied to this case, again, the argument of the trig function is just x, so that's, we can't use the chain rule on that, so that's actually the u of x. We know what the derivative of the sine of x is, that's the cosine, and then f of u is u squared. And the last one we'll talk about in class. It's a three-part thing. Actually, I'm going to just tell you about things that involve multiple parts. I'm just trying to think of one that I could do that doesn't involve the trig function. If I had f of x equals the square root of 3x squared plus 4x raised to the second power. Now I could just make this into the, well, actually let's make it to the third power, because otherwise it's just going to come out. So I could, make this into the 3/2 power. But if I were to use the chain rule, what I'd do is I would have f of v. I'd have to introduce another variable. F of v is the square root of v. So this whole thing here is v, and then v of u would be u cubed, and then u of x would be 3x squared plus 4x. And of course, well, hopefully you didn't just hear me, that you actually did try this. So let's let's go ahead and take the derivatives now. So f prime of u is -3, the exponent, times u subtracted 1. U prime of x equals 8x. So the derivative of 4x squared is 2 times 4, which is 8. Reduce the exponent by 1. Derivative of 3 is 0. So, the chain rule says that f prime of x equals f prime of u times u prime of x. So now we substitute in. So for f prime of u, we have -3u to the -4. For u prime of x, we have 8 times x. So we're going to, before we substitute u back in, let's just move the u to the denominator. So we take the negative exponent and move it to the denominator. So we get f prime of x equals 24x divided by u, which we go back here. U is 4x squared plus 3 raised to the 4th power. That's the answer. Okay, next one. These are just polynomials, straight polynomials. F prime of u is 9u squared. 3 times 3 is 9. Reduce the exponent by 1. U prime of x is going to be 5x to the 4th. 5x to the 4th plus 3 times 3 is 9. 9x squared plus 7. So the chain rule says that f prime of x equals f prime of u times u prime of x. So now we substitute in what we had from the previous step. Make sure you put in the parentheses. Now we can plug back in for u, so we get this whole thing in terms of x. And finally, I just moved the term that is not raised to a power at first and multiply by the quantity that is raised to a power last, with the constant first. Okay, same kind of deal here. F prime of u. So we get 2 times 5 halves. U, subtract 1 from 5 halves, you'll get 3 halves. U prime of x is 2x plus 2. 2x, x to the first power. Derivative of x is 1. The chain rule says that f prime of x equals f prime of u times u prime of x. So the two, you can see the 2's cancel out here. So I get 5 u to the 3 halves times 2x plus 2. Notice the parentheses. Then I substitute u back in. Put a parenthesis in there so I know that I'm raising the whole thing to power. And then just move the term that doesn't have a power to the in the front of the one that does have a power. Now, at some point, you don't, if you're really good at this, you don't have to go through all these steps. What you could do is you could think, okay, what I'm going to do is I'm going to reduce the exponent by 1, so I'm going to multiply 5 halves times 2, so that gives me 5. This doesn't change. The argument that the u of x doesn't change inside the parentheses or inside the square root. You just reduce the exponent. So I'd say I'm going to keep this the same, reduce the exponent by 1. That's that term. And then I'm going to take the derivative of what's inside, 2x plus 2, and I'm going to multiply that by the outside. So once you get good at this, you'll do it like that. Okay. Find f prime of u, which is, this is df du. Df du. So I'm taking the derivative with respect to u. The derivative of the sine is the cosine. E prime of x is 8x plus 2. Chain rule. F prime of x equals f prime of u times u prime of x. Go to the previous step. Write those out. Multiply them together. Put the parentheses there. Plug u back in. Multiply by the second term. Move the polynomial to the front.
We're going to feed you. Barbecue. Right?
Now, notice, if I left the parentheses off, I'd have 8x plus 2 times this whole thing. So to make sure that I am multiplying the whole thing, I need to put the parentheses there. Okay. F prime of view is going to be 5 times negative 4, which is negative 20. Decrease the exponent by 1. B prime of x equals the cosine of x. Chain rule, f prime of x equals f prime of u times u prime of x. What goes in? Notice I put this little dot here just to make sure that you know this is a multiplication. If I put this, if there's a parenthesis, I don't need the dot, but really, it's just a way of emphasizing that it's a multiplication. Okay, go back, find out what a u of x is. So you get negative 20. Use sine of x. Sine of x to the negative 5 power times the cosine of x. And let's see, what else am I going to do here? Move this to the denominator. It's like negative 20 sine of x divided by cosine of x to the 5th power. Now I could take sine over cosine is, a lot of times you want to rewrite these in terms of the ones that are in the numerator. So what I could have is, I just realized that I mixed these up here. Let's fix that. Okay, so this is cosine of x over sine of x. Okay. So I could do, cosine of x divided by sine of x times 1 over sine of x to the 4th power, and the cosine over the sine is the cotangent, and 1 over the sine is the cosecant. And then I could, are you right? This is the cosecant to the 4th of x. Just to put it in the form. If you gave me this, I'd be happy. I always want the negatives to become positives, to move them from the numerator to the denominator. But this would be extra. I'm not necessarily sure you would have to do or require you to do. Okay. So we have 1 over the square root of something. So we said that was 1 over the square root of u. You did the 1/2. It would be turned to the numerator to get it in the power rule form. So we get f prime of u is negative 1/2 times u to the negative 3/2 power. So I subtract 1 from negative 1/2. And here, just a simple polynomial. So I get 8x plus 3. So the chain rule is f prime of x equals f prime of u times u prime of x. So I'll get negative 1/2 u to the minus 3/2 times 8x plus 3. That's parentheses. And these things you keep saying this, it's because this is the 9th year I've taught this. I know what mistakes people make. So, bear with me. Okay, so now we need to get this entirely in terms of x. So we go back and find out what u of x was. So, plug that in. That's the negative 3/2 power. So all we have to do here is remove that to the denominator. So we get a negative sign. In the numerator we have 8x plus 3. We have a 2. And we have 4x squared plus 3x plus 7. raised to the positive 3 halves power. You don't need to rewrite this. This is the square root of the cube or something like that. Just leave it as 3 halves power. The only ones that you have to change back to square roots is half in the numerator, half in the denominator. Okay. Now the secant, you'll have to go to your book and find what the derivative of that is. It turns out that it's the secant tangent. And u prime of x, easy peasy, 10x. So the chain rule says f prime of x is equal to f prime of u times u prime of x. Secant u tangent u times 10x. It's not a function of x yet, so I'm going to now go back and find out what u was. So it's the secant of 5x squared. I'll put parentheses here just to emphasize. Tangent 5x squared times 10x. And typically you put the constant first, any polynomials next. Whether you put the secant first or the tangent first is really important. Notice the argument, you have to put the 5x in both the tangent and the secant because it starts out as the secant, the derivative is the secant tangent. So other cases of like that are the cosecant. Derivative of the cosecant is negative cotangent is cosecant. Now this is the product rule one. What we said was you have to go ahead and treat this part using the chain rule, and once you've done that you can plug that back in and then just use the formula for the product rule. So we said sine squared of x is a sine of x squared. So this is the term in the parentheses, so that's u of x. So this one's pretty easy. F prime of u is 2u. U prime of x is the cosine of x. So the chain rule says f prime of, and I know I used f here and g there, so maybe I should change that now. Just to be, I get used to doing f and I forget there are other letters in the alphabet. So there you go, g of u, g prime of u. Okay, so g prime of x, which is what I need over here, is going to be 2u times cosine x. And then we go back, find out what u was. So we get 2 sine x times cosine x. So we go over to here and write that down. 2 sine x cosine x. F prime of x is going to be equal to 20x cubed plus 0. So the product rule says that you take the first term multiplied by the derivative of the second plus derivative of the first term times the second. Now it doesn't really matter. I mean, you could put g of x times f prime of x because the order doesn't matter, but I'm multiplying it. But one has to be primed, one's not primed. That's the basic idea. And then the opposite here. So f of x is 5x to the fourth plus 4. G of x is 2 sine x cosine x. The second part, f prime of x is 20x cubed times g of x, which is sine of x squared. So now we can clean this up a little bit, not a whole lot. So I'm just going to move the 2 here out front, or I could multiply these both by 2, but just keep it out front, keep it factored. And then put the sine cosine, sine x cosine x. And then the second term, I just make that sine squared x instead of sine x squared. Okay, So there you go. So yeah, you just have to, if one of the terms in the product of two functions needs to be solved using the chain rule, then you just go and solve it using the chain rule and then plug it in later. Okay, so make sure you have all this done by Friday, except for the last problem. But don't try to say, I'll just wait till class, because you're not going to have time to get it all done. I may randomly check to make sure you've done all the problems except the last one, but we'll do another example of the last one. Okay, so let's do the solution for this last one. I just realized that I could have just made it to the 3/2 power, but it doesn't matter. We could still do it this way. So what we need to do is first we need to take f prime of v. So the derivative here, first we have to write this v to the 1/2 power. So you're going to get 1/2 v to the minus 1/2 power. Then you're going to do f prime of u. So we take the derivative here with respect to u. So that's 3u squared. And u prime of x is going to be 6x plus 4. And the chain rule says that f prime of x is equal to f prime of v times v prime of x times u prime of x. Pardon me, v prime of u. So that's, df dv times dv du times du dx. Okay, so you get 1/2 v to the minus 1/2 times 3u squared times 6x plus 4. So what I'm going to do is I'm going to move the v to the negative 1/2 to the denominator, as well as the 2. So you'll have 3u squared times 6x plus 4 divided by 2 times the square root of v. Didn't need to make the square root so big. Okay, so now first thing we're going to do is we're going to plug u back in. So you get 3 times this quantity u, which is 3x squared plus 4x to the second power, times 6x plus 4, all divided by 2 times the square root of v. And then we put v back in. Well, v is this whole thing, this cube part here. So what I'm going to do is I'm going to multiply I'm going to put this non-squared thing first. So I'm going to put this first, and I'm going to multiply each term by 3. So you have 18x plus 12. Put that in parentheses. 3x squared plus 4x squared divided by 2 times the square root of v, which is this whole thing that's in there. So it's 3x squared plus 4x cubed. Now, if we clean that up, we've got 3x squared plus 4 squared in the numerator. So that is, we can move that to the denominator and make it negative. So what you have here is, well, let's just let's just do a little thing on the side here. So if you had u squared over u to the, in this case, to the this thing in the middle is going to be to the 3/2 power. Okay, because you're taking the square root of something cubed. So if you then subtract, you get 2 minus 3/2, which is a half. So you get u to the 1/2. So that's actually in the numerator. So you would get this times the square root of 3x squared plus 4x all divided by 2. So what I do is combine these two. And the reason I did that is because, my observation initially, which I just didn't notice till now, is I could have worked the problem out a lot easier if I had rewritten this initial expression as 3x squared plus 4x to the 3/2 power. So in this case, I just have to do two things. I call f of u u to the 3/2 power, and u of x is 3x squared plus 4x. So when I take the derivative here, I'll get 3/2 u to the 1/2 power, and here I will get 6x plus 4. So if you figure out f prime of x here with just two terms, you get f prime of u times u prime of x. F prime of u is 3/2. I'm going to rewrite the square root to the 1/2 as the square root. Then you have 6x plus 4, and then I can plug u in there, and I'll multiply 3 times those. So there's two things. I'm going to take the square root of u, which is 3x squared plus 4x. So that's the u part. Let me square the u part. Let me move that over here. Then you'll have 3 times these, so you'll have 18x plus 12, and then you'll divide by 2. And you can see that was the easy way of doing it. But of course, I wasn't able to use the 3-part chain rule. So what I'm going to do is just put that next to the answer I got here, and you'll see they should be the same answer, which they are. But this solution does tell you how to do a 3-part one. So if this was the square root of the sine of this, then you'd know what to do. Maybe I'll change that next year. So if I gave you something like f of x equals the square root of the sine of 3x squared plus 4x. In this case, you can't simplify it like I did here.